There's no such thing as a perfect writer.
Hello, Surreal Headquarters. Okay, we're on.
I can count the days, but I know just what I'd find. Guess I lost my way. Maybe I've given up the will to fight. Now I'm calling out, falling fast. Visions of my life go spiraling past. If you hear me now, I need you to throw me a lifeline. Wash over my mind, show me what I couldn't see. Come and rescue me. I'm staying strong, but I don't see any change. I don't know how long I can last if my world just stays the same. Now I'm calling out, falling fast. Visions of my life go spiraling past. If you hear me now, then don't let the tidal waves break me. A time will erase me, trapped by my own memories. Come and rescue me. I've gone as far as I can go. There's just so much I'll never know. My castles crumble to the sea. So come and rescue me. You are the light that has to win. You are the color rushing in. You make me what I'm meant to be. So come and rescue me. Now I'm calling out, falling fast. Visions of my life go spiraling past. If you hear me now, just know as the story's unwinding, somehow I'm finding endings are not what they seem. Come and rescue me. Come and rescue me.
All right. Hello, hello, hello. Time for some atomic structure. Woohoo! Atoms. We're gonna make up everything. Here we go. So, let's see. I'm gonna go through the test review and start at the top. Gonna go through the bottom. If you have questions about a specific part of the test review, make sure that you hold them until I get to that part. I'll go through the part, I'll look at chat, and I'll look for questions over there. So if you are spamming chat, you're going to prevent people from getting their questions answered. If you are spamming with your question, I will time you out. Because if you are preventing other people from being able to get their questions in, you are not being conducive to this, so I will time you out. As we're looking through the study guide, remember the study guide is not exhaustive. Everything that you need to know is not on this study guide, okay? So you got to look at your notes, you got to do other stuff. Hopefully this is not your first time looking at this. If it is, you really got to work on studying, because that waiting for me to do the study guide for you is definitely not the way to study. Okay, so we are just going to start at the top with vocabulary review. Now, on the vocabulary review, the key thing is it's vocabulary. You either know it or you don't. So there's not much to learn on this other than the stupid ways to remember stuff. So if you don't know your vocabulary, that's square one, okay? You can't really do much if you don't know your vocabulary. Good Lord. Yes, this whole unit is easy. Okay, that's kind of the point. This is the foundational unit for the rest of the semester. If you don't learn this unit, you're going to have a lot of trouble, because literally the next unit starts with your understanding of how to do everything in this already, and then we build upon that. Okay, so if this was easy, that's a good sign. So I'm just going to start right away. The way that you should do vocabulary whenever you're given vocabulary review is you should not read the definitions until you are looking for a specific definition. So you read the vocabulary word, you come up with the definition in your brain first, and then you look for that exact definition. So that way you're not wasting a lot of time reading and rereading and rereading and rereading. Instead, you already know the answer, so you just find it to match it up. Okay? So real quick, let's go. Number one, proton. Okay, protons. We know those are positively charged subatomic particles located in the nucleus. So, particles, no charge. Nope. 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 Positively charged particle that exists in the nucleus of the atom. Great. Green. And this was A, B, C, D, E. Okay. Beautiful. Okay. Neutron. Those are neutrally charged. They are subatomic particles. They are in the nucleus. So, particle with no charge that exists in the nucleus. Here we go. A. Cool. Moving on. Electron. Negatively charged subatomic particle. There we go. D. This should be very easy. It's vocabulary, guys. Doesn't get any easier than vocabulary. Subatomic particle. Okay. Protons, neutrons, and electrons. Yep. That's it. Those are our subatomic particles. Okay. Nucleus. Center of an atom contains the atom's mass. Yep. Look at us go. Okay. Number 6. Group or family of elements. So, atoms in the same element which have different numbers of neutrons in the nucleus. Nope. Elements with similar properties listed in a single column. Yep. Okay, that is our family. So, FG. Okay, the periodic table. Woohoo, that's the best thing ever. Okay, that is our religious text for this course. Chart of the elements arranged, constantly updated. The number one place you should go whenever you have a chemistry question. Periodic table. Chemical symbol. An element, nope. The abbreviation, yep. Okay, cool. Mass number. Total number of protons and neutrons. Very good. There we go. H. Protons plus neutrons gives us our mass number. Isotope, that is the same element with different number of neutrons, which means that they have a different mass number. If you have a different number of neutrons, but you're the same element, means you have the same number of protons, different number of neutrons, add them together, you get different mass numbers. Metalloid, element that has properties of a metal and a non-metal. They can't make up their mind, okay? They act as both. They're by case-by-case basis, all right? So, there we go. Left side done. Should be very easy, okay? Right side. Let's start. Atomic number. Atom with more protons? Nope. Way to refer to the element described the number of protons in the nucleus. That's exactly it. Okay, atomic number is the number of protons it has. Energy level. Electron, nope. How electrons are arranged around an atom. Yeah. Let's keep checking though. Average of gain shape, row, number, atom. So, yep, D. Change. Okay, cool. Anion. Okay, remember, anion is a negatively charged ion. So, here we go. Atom that has gained or lost electrons. Nope, that's an ion. Atom with more electrons than protons. That's going to be negatively charged. That's exactly right. Okay. Moving on. Cation. That's our positively charged one. Atom with more protons than electrons. It has a positive charge because of that. Okay. Valence electron. Electron found in the highest energy level. That is our valence electron. Very easy. Okay. Very easy to remember. Valence is outermost. A period. That is our row. Okay, H. Then we have our ion. That is an atom that has either gained or lost electrons. It becomes charged. A charged atom. That's our ion. Okay. Atomic number again. We just did an atomic number. Now we have atomic number again because it's a different way of saying the same thing. Okay. Number of protons in an atom. That's our atomic number. Malleable. Here's your vocabulary word that you should know. This is what I mean by if you don't know your vocab, then you just don't know it. Okay, malleable. No, nothing's really here to help you. Malleable. Mal kind of looks like mallet. A mallet is a hammer. Malleable means you can hammer it to shape, so you can change shape without breaking. Okay, that's our best bet there. Okay, there's really no great way to remember that. You just got to know it. Conductive, allows transfer of heat and electricity. We learned that last semester. You definitely should know that one. And then average atomic mass. Okay, last one. Remember, average atomic mass is different than the mass number. Oh, that was an E. Average atomic mass is the average of all the isotopes. Okay, so for each isotope, you have the mass number. Protons plus neutrons. For the average atomic mass, you take all of those isotopes and then you average them together and you get the average. If it is a decimal, it's an average atomic mass. You cannot have a decimal mass number, okay? When you add up your protons and your neutrons, you're never going to get a decimal. You will always get a whole number. Okay, so this is vocabulary. If you don't know, if you missed one of these, that's kind of a bad sign. You need to make sure that you know your vocabulary. So since the test is tomorrow, you got to drill that today. There's a Quizlet. Just search atomic structure. There's all these in Quizlet. And you need to make sure you're drilling it tomorrow morning as well. Okay, you have to know your vocabulary. Okay, there's really no excuse for it. Okay, so finished the vocabulary. Any questions over vocabulary? For the rest of the one, you're going to need your periodic table. Instead of putting it up on the screen, I'm just going to reference it as I look at it in front of me. You should also have your periodic table whenever you are working on something in chemistry or in intro to chemistry like we are doing. You should pretty much always have your periodic table because it gives you so many answers. Okay, you just have to know how to read it. Okay, we've learned about 6, 7, 8 different ways to read the periodic table. There are so many more. If you just read them, it gives you ideas of the trends, gives you properties. It just gives you a lot. Okay, so whenever you're trying to do something, you must be looking at your periodic table. Okay, what's the atomic number of SC? Okay, so first things first, you need to learn how to locate things on the periodic table. SC, that's our chemical symbol. So we just look through, we find the one that is S and C. Now remember, for chemical symbol, it must be SC. It is not SC. This is South Carolina, and that is a state. This is scandium, and it is an element, okay? So this is an element. This is a state, okay? We do not want to go to South Carolina. We want scandium. So we look up SC. It is, let's see, let's try to find it. number 21. Okay, we find SC, number 21. That's the atomic number, so there we go, 21. Very cool. Okay. Then we have, what is the atomic mass of IR? Okay, we look up IR, it's iridium, it's a transition metal. There it is, 77. Okay, iridium. Iridium. Okay, number 77. It says, what's the atomic mass? So we find the average atomic mass for it. It is 192.22. Okay, it asks for the atomic mass. So we list our average atomic mass right there. 192.22. Okay. How many protons does an atom of sulfur have? Okay, so here we go. This is what I mean by vocabulary. Okay, we have the atomic number, the atomic mass, and then we have how many protons. Okay, these two go hand in hand. Okay, same thing. If you do not know that atomic number is number of protons, you're going to have trouble answering these questions. How many protons does an atom of sulfur have? You look it up. Sulfur has an atomic number of 16. Therefore, it has 16 protons. Okay, the only thing that matters for the identity of the element, okay, is the number of protons. Neutrons can change. Electrons can change. Okay, the way that it's configured, the electrons where they are can change. The only thing that matters is the number of protons. The number of protons is the name tag. When you say it is sulfur, you know for sure it has 16 protons. When you say it has 16 protons, you know for sure it is sulfur. Okay, the only thing that matters is protons. So when it says how many protons does an atom have, all you do is look up the look on the periodic table, find the atomic number, you're good to go, 16. Okay? So, there we go. First page done. Okay, first page done. Oh, now, granted, it was all vocabulary, and even this was all vocabulary. So, really not that bad. Really not that hard. It does get harder. Not so much for this unit, but it will get harder as we go throughout the year. Okay, but the things that are harder are like steps beyond this. We got to master this, and then we can build up to the harder stuff. So make sure that we've got this mastered. Make sure we know our vocabulary and we know our concepts. Okay, any questions over these? Alright, I am going to move on. I'm going to page 2. Well, I will as soon as my thing doesn't crash. There we are. Page 2. Cool. Page 2. Alright, why is it not updating on the screen, though? Let's try this. See why it's not working. Alright, why are you not updating? My screen does not I am on page 2, and on the stream it still is on page 1. Let's see. Troubleshooting. Okay. Okay, did it work now? There we go. Alright, that was weird. Zoom in. And let's go from the top. Here we go. Complete the chart for characteristics of the subatomic particles. So that's all we got to do, okay? Subatomic particles. Here again. Vocabulary. Do you know your vocabulary? Yes or no? That's all this is asking. Proton, charge. Okay, well, I know my vocabulary for proton, so I know that the charge is positive. Okay, electron, charge, negative. Neutron, charge, it has no charge. Boom. Okay, mass compared to electron. Well, I know electrons basically have zero mass. Okay, and they are located in the shell, in the cloud. Okay, and the electron cloud around the nucleus. Okay, these are in the nucleus. Same with these, in the nucleus. This is literally vocabulary. Do you know what each of these three things are? Okay, so electrons, remember, they're 2,000 times smaller. Well, 1,800, so roughly 2,000 times smaller than protons. So we don't really care about the mass of the electrons. They're zero in a sense, because remember, protons are 1 AMU, atomic mass unit. Neutrons are 1 AMU, atomic mass unit. Okay, electrons are essentially 0 AMU. Okay, it's like point and then 4 zeros and then a 5 or something along those lines. Okay, they are roughly 0 AMU. So when you compare them to the mass compared to the electron, okay, we can just say much, much larger. Sure, that's all we need to know. Mass compared to the neutron, it's equal. Okay, protons and neutrons are equal in mass to each other. They're both 1 AMU. Okay, and this is much larger. So all this is do you know your vocabulary? That's literally it. Do you know your vocabulary? Pretty much most of this unit is do you know your vocabulary? And if you don't know your vocabulary, you're going to think it's hard. And if you know your vocabulary, it's going to be so easy that you're going to wish that we were on this unit all the time. Okay? Use the diagram to answer questions 1 through 3. Okay, the model below represents an atom and its structure. So here we go. We have a Bohr model. We have our P, protons and neutrons. And then we have different rings. So we have our first ring with 2 electrons and our second ring with 1, 2, 3, 4, 5, 6 electrons. So I'm going to write that all out here. So in total, I have 8 electrons right there. So I have 8 protons, 8 neutrons, 8 electrons. And if you wanted to, you could immediately go to your periodic table. 8 protons, atomic number 8, oxygen. Okay, so I know that this is oxygen. Okay, so this is oxygen. And then its mass, protons plus neutrons, is going to be 16. Okay, remember we have oxygen hyphen 16. That is our name of the element. Then the mass number. Okay, so oxygen 16. 8 electrons. This is all stuff that I can get just from this diagram. Okay, now let's go see what the questions are. What would happen if a proton was added to the atom? Okay, so keywords here. Proton was added. Okay, proton was added. When you change the number of protons, you have to change what element it is. Okay? The only thing that matters for the identity of the elements is the number of protons. That's it. If you change the proton, you have a new element. That's it. That's it. Do you know your vocabulary? What would happen if a neutron, here we go, new word, neutron. Okay, what would happen if a neutron was added to the atom? Okay, that would now be P8 and 9. Okay, so we know P8, 8 protons, it must be oxygen. So right away, we can get rid of, it would become a different element. Okay, right away, you have to add a proton for that to be the case. So we now have isotope, isotope, ion. Okay, ions deal with charges. If we didn't do anything to the electrons, then we are out with the ion. Okay, instead, we now have our isotopes. This isotope says a mass of 18. This one says an isotope with a +1 charge. Okay, this is kind of funny because both of these are wrong, but it is the B because it's 8 plus 9, so this is oxygen 17. There's a typo on this one. Okay, it should be a mass of 17, not 18. Okay, but this one's definitely wrong because isotopes don't have charges. Ions have charges. Okay, so that one's terribly, terribly wrong. Okay? So there we go. Number 1, number 2, pretty easy. Number 2 had a typo in it, but we can easily see that it was a typo, and the other 3 are just flat out wrong. Okay? What would happen if an electron was removed from the atom? Here we go. Make sure you're paying attention to the key words. If you are not paying attention to the keywords, pretty much these are the exact same question, and you can answer them however you want to, okay? But if you pay attention to the keywords, you'll see they are very different, okay? If we change our number of electrons, what would happen if electron was removed? So now we have 7 electrons. We have 8 protons. Okay, you add those together. 7 negatives, 8 positives leaves us with 1 positive. Okay, that's what it leaves us. 7 negatives, 8 positives leaves us with 1 positive. So over here, form an ion with a 1 positive charge. Boom, we're done. I don't even have to read the rest. I know this one's right. Okay? You don't even have to read the rest. If you already know the exact and you are perfectly confident, then don't bother to read the rest of them. Alright, I'll keep this up here as we go through this one. Use the model of atoms A, B, and C shown below to answer the questions on the right. Okay, we have atom A, we have atom B, and we have atom C. Okay, A, B, and C. Now, it's a little hard to read. This is 8, 8, 8, 10, 10, 10, 8, 10, 8. Okay? So, which atoms are forms of the same element? Okay, how do we know what the element is? There's only one thing that determines what element it is, and that is the number of protons. Here we go. Atom A, 8 protons. Atom B, 10 protons. Not the same number of protons, therefore not the same element. C, 8 protons. Boom. Okay, A and C. They both have 8 protons. They both are the same element. Are any of the atoms ions? Now, here's your vocab lesson. Ions, this is it. Do you know what ions are? That's all it's asking. And ions are charged atoms, meaning they have a different number of protons and electrons. 8 protons, 8 electrons, not an ion. 10 protons, 10 electrons, not an ion. 8 protons, 8 electrons, not an ion. That's a no. None of them are ions. Okay? Are any of the atoms isotopes? Well, yes. Do you know what isotopes mean? Isotopes are the same element. We already know A and C are the same element with different numbers of neutrons. We have 8 protons, 8 neutrons. 8 protons, 10 neutrons. Yes, A and C are isotopes. If you have the same number of protons, different number of neutrons, you are isotopes. That's it. Okay, that's the definition of the word. Okay, what is the atomic number of atom A? Well, how many protons does it have? 8. Boom, it's 8. What's the mass number of atom B? Mass number, protons plus neutrons. This is literally vocabulary. 10 plus 10. Okay, 10 plus 10 gives us 20. Our mass is 20. Our mass number is 20 for atom B. Give the element name and isotope notation of atom C. Atom C, the name is determined by its atomic number. The atomic number is determined by the number of protons. 8 protons. Boom. Oxygen. Okay. And then it says isotope notation. Now, here we go. We can do oxygen and then the mass number, which is 18. Or you can write it in isotopic notation over here, right? We have step 1 for isotopic notation, symbol, O. Okay, step 2, top left corner, you put your mass, 18. Step 3, bottom left corner, you put your atomic number, 8. Okay, step 4, top right, you put your charge, 8 protons, 8 electrons. There is no charge, so therefore we can leave the top right blank. There we go, isotopic notation. Boom, oxygen. Mass top left, 18. Okay, atomic number bottom left, 8. And we got our mass from protons plus neutrons. Okay, so both of these are the exact same thing. Okay, one writes it out with a hyphen then the mass number. The other shows you the mass number in the top left and the atomic number in the bottom left. Okay, boom, done. Draw a Bohr model for the following elements. Okay, so I am actually, hold on. Any questions until we move on to Bohr models? I'm going to take a break real quick. If you have questions before we move on to Bohr models, you need to get them into the chat now, and we will answer them before we move on. Alright, I'm moving on. Number 7, draw Bohr models. I'm going to draw them in my empty space down here instead of in that little box because I'm working with a stylus and I am not that great with it. Okay, draw a Bohr model for the following elements. Silicon 29. First thing you should do, look up silicon. Okay? List out your stuff. Silicon. Okay? That means it is number 14. Okay? My atomic number is 14. That means my protons, 14. My neutrons, 29. That's my mass number. So 29 is my mass number minus my number of protons is equal to my neutrons. Okay, so 29 minus 14 is 15. And then electrons are going to be, it does not say it has a charge, so therefore it's neutral. And if it's neutral, my electrons are the same as my protons, 14. Okay, so this information I need to put into a Bohr model. Okay, so first things first, you write in your nucleus. So protons, okay, equals 14. Neutrons is equal to 15. Okay, there is my nucleus. Now, second thing you do, you find what row it's on. Okay, silicon is on the 3rd period of the periodic table, so you draw 3 circles around your nucleus. Hopefully you can draw a little bit better than me. Okay, but alas, I don't know how people paint lots of pictures on this. You're crazy. There we go. Now we're going to add in our 14 electrons. Okay? 14 electrons. First circle. First circle can hold 2 electrons. 1, 2. Okay? Second circle can hold 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I've drawn 10. I had 14. I've drawn 10. I have 4 left. So we're going to do 1, 2, 3, 4. Okay, there we go. There's my Bohr model. Moving on. Okay, so all of this shows this information. Okay, the Bohr model shows this information. Now, is yours going to be as messy as mine? Hopefully not. But I'm not drawing on paper. I'm drawing on a tablet. See, tablet. And I suck at it. And you're just going to have to deal with it. Okay. Next one. Chlorine ion. So, chlorine ion. Ion. Atomic number is equal to chlorine. Find chlorine, 17. That means protons equal 17. Neutrons, it does not give us a mass. Uh-oh. How do we find the mass if it doesn't give us a mass? Well, we turn to our trusty periodic table. The average atomic mass is 35.45. Okay, so the average equals 35.45. Since it does not give us a mass number, we can go ahead and assume, just use the average, okay? If you don't have something, using the average is better than using nothing. So they don't give it to us, so we have to use your average, 35.45. You round it to the nearest whole number, that's 35. So 35 minus 17 is equal to our neutrons, okay? 35 minus 17, that is 10 gets you to 27, 20 would get you to 37, it's 2 less than that, so it is 18. Okay, and then we have electrons. Now, chlorine ion. It doesn't tell us what ion it forms, but we should know. We look at chlorine, okay? Find chlorine, number 17. It is in the periodic table in the group 17. Funny, atomic number 17 is in group 17. We know that group 17 has 7 valence electrons. So what I'm going to do is I'm going to draw it without the ion right now. So 17 protons means theoretically if it was neutral. So if neutral electrons would equal 17. So I'm going to go ahead and draw that. So we've got protons. Okay, neutrons in my nucleus. Okay, now I draw my first ring. I draw my second ring. And it is in period 3, so I will draw a third ring. Okay, cool. Put in my electrons. So, first ring, 2. Second ring, 8. Okay, now, that's 10. I'm left with 7 more, so here we go. 1, 2, 3, 4, 5, 6, 7. So, group 17 are the halogens. Okay, again, another memorization. This whole unit's memorization. Halogens have 7 valence electrons. So, we have 7 valence electrons. You can see on the outside ring, I have 7 electrons. 7 valence electrons. Okay, we want a full octet. Octet means 8. Okay, full octet. So 7 valence electrons needs to turn into 8 valence electrons. If we gain a electron, we now have 8 valence electrons, which means our 17 went to 18. If you have 17 protons and 18 electrons, you add those together, you get a charge of 1 minus. So we need to draw in our brackets. Bracket, bracket, minus. You have to show your charge. Okay, we can count the number of electrons, and we can see that it is 1 more than our number of protons, so therefore our charge is going to be -1. Electrons are negative. We gained an electron. When you gain an electron, you gain a negative charge, and we gained 1 electron, so our charge is 1 negative. So we draw that in, 1 negative. And this is the Bohr model for the chlorine ion. Now, we figured out how many electrons we had to gain. We drew that in on the Bohr model. We added a charge to the Bohr model. This is now a Bohr model of an ion, and we are done. Okay, so we have the Bohr model of a neutral atom where your protons are equal to your electrons. And we have a Bohr model of a chlorine ion where your protons are not equal to your electrons. Your electrons are based on what you have to do to become a full octet, what you have to do to fill up your valence shell. Okay, so there you go. So we have to fill up our valence shell by gaining 1 electron, and therefore we draw in the extra electron on our Bohr model, making it the Bohr model of the chlorine ion. Any questions over Bohr models? All right, very, very low amount of questions today, so I'll just keep moving on. All right, trends. Here we go, trends. So this one, you absolutely need your periodic table for this one. Absolutely, absolutely, absolutely. Okay, so when we look at identifying the element, okay, the first thing we need to look at is our periodic table. Again, you should always be looking at your periodic table. The element with the fewest valence electrons. So when we are identifying elements this way, we have to make sure we look at the keyword. Okay, fewest valence electrons in period 5. So you look at period 5 and you just go all the way over. Okay, you look at period 5, you go across. Now, let's see. Let's see if I can do this real quick. Nope, not working. Let's try again. Nope, not working. Alright, I was trying to put one up on the screen, but it's not going to pull into the whiteboard. And there's no background for it. Alright. Cool. So, as we go over, you're just going to have to follow along. Actually, hold on. What if I do this? Nope, not working. Oh well. You will just have to follow along on your periodic table. Okay? So, period 5. You look over, count down your periods. 1, 2, 3, 4, 5. That's the period that starts with rubidium. It has a 5 literally next to it. Okay? 1, 2, 3, 4, 5. Okay? 1, 2, 3, 4, 5. Okay? You go all the way across. This is the entire period 5. Okay, starts with rubidium, goes all the way over to xenon. Okay? So it says the element with the fewest valence electrons. Okay, valence electrons. Can you read the periodic table for valence electrons? That's all this is asking. Okay, we got group 1, group 2, group 3, or 3 through 12, 13, 14, 15, 16, 17, 18. Okay, so 1, 2, we know 1 has 1 valence electron, 2 has 2, 13 has 3, 4, 5, all the way up to 8. So the fewest number would be in group 1. So group 1, period 5, that is our element with the fewest valence electrons. Therefore, that is going to be rubidium. Boom. Okay, most reactive metal in group 2A. Remember, metal reactivity goes down and to the left. Okay, this is metal reactivity. Remember, reactivity is how reactive is it? Is it likely to get into a reaction, or is it likely to stay by itself? Okay, as you go down the periodic table and all the way to the left for your metals, okay, that is the most reactive is down in the bottom left corner. So group 2A. When you look at group 2A, you'll see that group 2, okay, is also labeled 2A. So group 2 all the way down would be radium. So that's RA. Okay? Least reactive in group 7A. Now, this is where it gets a little confusing, because some periodic tables have 1 through 18, and some have 1A, 2A, 3B, 4B, and then you get over to 3A, 4A. Okay, that's the main group, excluding the transition metals. Okay, so if you look at it at the top of your periodic table, you will see that it says 1, 1A, 2, 2A, okay, 3, 3B, 4, 4B, so on and so forth, to 13, 3A, 14, 4A, okay, 15, 5A, so it all depends on how it's labeled as to which one you use, okay? This is group 7A, so that's the same on here. You'll see group 17, and then it has the Roman numeral VIIA, okay? This is the Roman numeral for 7, so group 7A, okay? Least reactive element, 7A, is nonmetals. They are nonmetals. So our nonmetal reactivity goes across and up. Okay, this is nonmetal reactivity. Okay, so the lower you are, the least reactive you are. So in group 17 or group 7A, we want the very lowest, which is going to be astatine. Okay, and that's going to give us our least reactive element in there. Liquid metal. There's only one metal that is liquid at room temperature, therefore it is referred to as liquid metal. Now remember, just because there's only one at room temperature that's liquid, you can melt any metal, okay? You get it hot enough, it's going to melt, okay? So anything can be a liquid. Liquid is not it's not specifically only two elements. It's just those two elements are liquid at room temperature, okay, which is roughly 25 degrees Celsius, about 75 degrees Fahrenheit. Okay, that is what we're talking about when it says liquid metal. It means at room temperature, and it is mercury, Hg. Okay, the way I remember that, and you don't have to memorize these, Hg, heavy gunk, okay, because mercury is very heavy, and it gets a little gunky, okay. Name of group 8A. So, look at our table, 8, okay, 8V, and then 3 I's. That is 8A, also known as group 18. Okay, that's on the very end. Group 18 on the very end right here. These are the inert gases that don't mix with anyone. They are the noble gases. So name of group, that would be noble gases. Boom. Okay, gas in group 5A. Okay, group 15, group 5A. Okay, the one that is gas at room temperature is nitrogen. Okay? This is just, can you read your periodic table, yes or no? Period 4, element that forms a +3 ion. Now, period 4. We count down. Okay, period 1, period 2, period 3, period 4. Okay, it's the one that forms a +3 ion. The ones that form +3 ions are in group 13. So you bring it all the way over to group 13, and it is this element right here. You look at your periodic table, it is gallium. Okay, Ga. Okay. Element with the lowest melting point in group 1A. Okay, group 1A. This is kind of a trick question in a sense, but not really. Group 1A are our alkali metals. Okay, group 1A are alkali metals, except for hydrogen. These are all metals. This one's hydrogen. These are all solid at room temperature. This one's gas. So when it says with the lowest melting point, melting is going from solid to liquid. Well, this one at room temperature is already gas. So obviously it has the lowest melting point, and that's hydrogen. Okay, obviously. So then we have metalloid in period 3. Okay, read over. Okay, metalloids are these that are on the stair step. Okay, we have them covered. You go down, down, so on and so forth. Stair step. Okay, on your periodic table, there is a very bold line that goes like this. Okay, is the ones that kind of straddle the line are the metalloids. So metalloid in period 3, 1, 2, 3. You go all the way across. There's only one. Okay, and that is silicon. Probably the most famous metalloid. Okay, most conductive element in group 17. Okay, group 17 is the halogens. Boom. Okay, there is a metalloid and nonmetals. Okay, metalloid and nonmetals. That's what is in group 17. Now, nonmetals we know are non-conductive. Metalloids we know are semi-conductive. They are sometimes conductive. So, by default, the metalloid that is in that group is the most conductive. Well, it's easy to be the most conductive when everyone else isn't conductive at all. Okay, so that is why it is the most conductive. Okay, so when you're trying to identify and read the periodic table, remember, in your foldable, we have about 8 different ways to read the periodic table. You got to be able to do them. Okay. And then finally, real quick, label the following periodic table using the terms. Okay, this is super easy. Alkali metals. Boom. That's very thin. Okay, those are our alkali. 2, this is our alkaline earth. Okay, 3 is pointing to this row right here. Actually, no, it's not. 3 is just on this side. Okay. We're going to skip 3. We're going to go to 4, which shows the middle block. The middle block are our transition metals. Okay, transition metals. I'm not writing the full thing in there because you know what I mean. Okay, we'll skip to the easy ones. This one is group 17. We know group 17 are our halogens. Group 18 are the noble gases. Okay, this is this area over here, so 9 is nonmetals. Okay, remember everything right of the staircase are nonmetals. The staircase are metalloids. The row down here, the first one starts with lanthanum, and they are called the lanthanides. And then this one starts with actinium, and these are the actinides. That means over here, number 3 is regarding all of this, and these are all our metals. Everything left of the staircase, except for hydrogen, are metals. Everything on the staircase is a metalloid. Everything to the right is a non-metal. Okay, there we go, labeling the groups and families that we need to know about, and we are done with the study guide. Pretty darn easy. Okay, this is basically, this entire unit comes over. Do you know your vocabulary words? Yes? Great. No? You're in for a world of hurt. Okay, that's literally all it comes down to. Do you know the vocabulary words? Because if you know the vocabulary words, you're able to then apply everything. Okay, if the definition is protons plus neutrons, and they give you protons and they give you neutrons, all you do is add them together because you know how to do that from the definition. Okay, that's it. Do you know how to identify the groups and the families? Well, what's the definition of noble gases? Oh, group 18? Great. I can label group 18 as noble gases. Oh, they have a full octet already, so they're non-reactive? Great. I know that because it's literally the definition. That's it. This test is literally definitions. It's all vocabulary, and then using the vocabulary definitions to then apply to the problems. Okay? Barely any math. The math is how do I get to 8? Plus 3 minus 4, so on and so forth. That's all the math there is. Add in your protons and neutrons, and then if you have your mass number minus your protons, it's literally simple math, okay? So this is it. And then, do you know the definition of metals, nonmetals, and metalloids, okay? Metals. We had this in the other packet that you did before you got this one, the 6 pages. Metals, they're shiny. They're mostly solid at room temperature except for mercury. They're high melting point, high boiling point, conductive of heat and electricity. Obviously, guys, you're smart. You know that wires are made out of metal. Why are they made out of metal? Because they conduct electricity. Therefore, metals conduct electricity. Okay? Do not overthink or underthink these problems. Just, like, follow them to their conclusion. I know that wires are made out of metal. Therefore, metals must make good conductors. Therefore, metals must be able to be stretched into wires. Okay, that's a vocabulary word, ductile. Okay, so I know metals are ductile because they can be stretched into wires because I know wires are made out of metal. I know that nonmetals are dull. I know that nonmetals cannot be stretched into the wire because they're brittle and break. I know that they don't conduct electricity. I know that they don't really conduct heat. I know that they are insulators. Okay, I know they're on the right of the periodic table. I know that metalloids on the staircase are a case-by-case basis. Some conduct electricity, some don't. Some conduct electricity based on conditions, and some you can change those conditions so they don't conduct electricity. They're the weird ones. I know that the main group is 1, 2, 13 through 18. I know that the transition metals are in the middle. I know how to find valence electrons. They are the electrons on the outermost, and you can use your periodic table to do that. Group 1 has 1. Group 2 has 2 valence electrons. Group 13 or 3A has 3 valence electrons. Group 14 or 4A has 4 valence electrons. Group 15 has 5. 16 has 6. 17 has 7. 18 has 8, except for helium, because I know the first energy level can only have 2 electrons. And I know helium, which has 2 protons, and is going to be neutral with 2 electrons. Okay, so it has 2 because it still has a full valence shell, so we group it with the noble gases. This is it. It sounds really smart. You can sound so smart when you go through all this, but really, it's not hard. Do you know the definition? Can you apply the definition? Yes, you're done. You sound so smart. Okay? If either of those are a no, you're going to have trouble. No, I'm not going to show my dog. Thank you, though. Oh, I'm very confused at this question. Uh-oh. That's not a good sign. How is AT the least reactive? It has the most atomic mass. Okay, this is kind of scary because we have never talked about reactivity and atomic mass going hand in hand. That's kind of scary. Atomic mass has nothing to do with reactivity. Atomic mass only has to do with its isotopes and the mass numbers of the isotopes. Okay, the more protons and neutrons it has, the more atomic mass it has. That doesn't have anything to do with reactivity. Reactivity is pretty much only dictated by the electrons. Okay? The ones with electrons that are very close to being a full octet are reactive. Group 1, Group 2, they only have to lose 1 or lose 2 valence electrons and then they're stable. They're highly reactive. Group 17 or Group 16, Group 17, they only have to gain 1 or 2 electrons. They're highly reactive. It has nothing to do with the atomic mass. Now, where you might be confused, you might be confusing it, is with the metal reactivity right here. Metal reactivity. The trend is down and to the left. As you go down, it's more reactive, and as you go to the left, it's more reactive for metals only. Metals only. That's this part of the periodic table, okay? Everything up to the staircase. Metals only. Okay, non-metals, it's the exact opposite. The up and to the right is the most reactive. So for non-metals, this side of the periodic table, up and to the right is the most reactive, with fluorine being the most reactive element. Okay, we don't care about group 18, the noble gases, because they are not reactive. They have a full valence shell. Okay, so therefore they don't play into the reactivity because they're not reactive. So when we are looking at non-metals, and it said in group 7A, which is this one right here, group 17, 7A. We want to know what the least reactive is, so you do the opposite of the trend. If the trend is up and to the right, that means up and to the right is the most reactive, which means down is the least reactive. Okay, and you go down, and the last one in there that is on your periodic table is astatine, AT. Okay, the one that's below it, I think, is tennessine, maybe, and it is not stable enough to really know its reactivity. Okay? So it has nothing to do with atomic mass. Reactivity only has to do with its electrons. And we're going to get into that. That's our next unit is all about bonding. Okay, but we gotta be able, gotta be able to do valence electrons before we can get there. Alright, last fall call for questions. I'm done with the study guide. You need to go through it. My class, you have 6 pages from the day before that you could go through. You have your notes. You have all those handouts. You have those back page of the Bohr model that we never finished. I left a lot of notes for you. If you're having trouble, you need to be able to go and relearn stuff. Here's where you should be going. Look, watch this. Alright, let's try this. And alright, this is where you should be looking if you are having trouble with stuff. You should be looking at YouTube. You should go to this guy, Tyler DeWitt, who has very, very, very good chemistry videos. Okay, now, he does go too high. He does get up into college level chemistry. You obviously don't need to go that high. Okay, when you click on Tyler DeWitt, you can either search atomic structure. Okay, boom, basic atomic structure. Boom, discovering the neutron. Okay, that's history. Boom, elements and isotopes. That is a full playlist of 5 videos. Boom, look at this. Look at this. 6 minutes, 7 minutes, 4 minutes, 7 minutes. If you don't remember what isotopes are, if you need help doing practice problems, look at this. Boom.
For me,
Grammarly. Ads. Always. On the time. Okay, that's YouTube. Gotta make money.
In this video, we're going to look at how to figure out and solve for all of these
Look at this.
characteristics
Look at this.
or properties.
Oh my gosh. Look at him go through it. Oh my gosh. Oh my gosh. Look at all these resources that we could do. Yes. Thumbs up. Like, subscribe, ring the bell. Okay, there you go. Tyler DeWitt. Okay, that is where you want to go. You want to search what you are having trouble with, and you go and get retaught it. If you did not get it in class, you go, you look up YouTube, you figure it out. You don't like him? Great. Type it in. Atomic structure. Boom, that's all you got to do. Look, there he is again. Look, Atomic School's got one. Oh, look, there we are, right there. Okay, Crash Course has history. More, look at this. Look at this. Organic Chemistry Tutor goes through it. Bozeman Science goes through some stuff. Okay, that is all over YouTube. Okay, it is good to go. Okay, that is all you have to do. You just got to go reteach yourself. If the notes are not working, if you don't remember how to do something, you take the keywords, you type them into YouTube. There are videos on it. Okay, there are so many chemistry videos on it. Boom. How do you calculate valence electrons? You look at the periodic table. This is how you do it. Right here. That's all you got to do. You look here. Valence electrons, the electrons in the outermost energy level. You could go and draw a Bohr model for every single one you're looking at. God, that would take a long time. Okay, luckily for us, all the information we need is given to us in our Bible of Chemistry, the periodic table. You look here. Group 1, 1 valence electron. Oh my gosh, I'm gonna write this out. Oh boy. You're getting me going. Okay, look at this. Look at this. 1, 2, 3, 4, 5, 6, 7, 8. Everything in here. 1, 2, 3, 4, 5, 6, 7. And you start here for 8 because helium, special. Okay, helium only has 2. But helium has a full valence shell, so therefore it's listed with the other 8. That's it. 1, 2, 3, 4, 5, 6, 7, 8. That's how many valence electrons each of these have. You find it in the periodic table. If you are looking for an element in the periodic table, and it is right here. Boom. It is in group 2. It has 2 valence electrons. Boom. Group 6, 6 valence electrons. Boom. Group 8, 8 valence electrons. Done. Done. Therefore, now that we know all this, we can move on and we can figure out the number of ions it will make. Everything in here. Look at this. Look at this. Look at this. Everything in here. 1 valence electron. 1 valence electron. You need to get rid of that 1 valence electron. Get rid of it. Goodbye. You form a +1 ion. Boom. +1. Boom, +2. Get rid of those 2. 3. Boom, +3. 4. You can go either way, right? Okay, that's 4, plus or minus. Who knows if it's easier? Plus or minus 4. Okay, roughly the same. 5. Boom. Okay, you can either lose 5 or gain 3. Boom, easier to gain 3. Okay, 6. Boom. Easier to lose 2. 7. You lose 1. Or, sorry, I am backwards. 4, plus or minus 4. Group 5, you have 5 valence electrons, you gain 3. You gain 3 negatives, you become a -3 charge. 6, you gain 2. Gain 2 electrons, 2 negatives, you are 2 minus. That's your ion. 7, you gain 1 electron, you become 1 minus. That's your ion charge. Group 18, you got a full valence set, you are happy. Smiley face. You do not need to lose or gain any electrons because your valence shell is already full. So, read the periodic table. Do you know what group it's in? Therefore, you know how many valence electrons are. Do you know how many valence electrons? Therefore, you know what ion it will form. Do you know what ion it will form? Therefore, you know how it will bond. And we do that literally this week. After this test, we will get into bonding. Okay? But to get into bonding, you have to know how ions are made. To know how ions are made, you have to know what group it's in. To know what group it's in, you need the valence electrons. Okay? To know the valence electrons, you got to know 2, 8, 18, so on and so forth. You put them in the outermost energy level, valence electrons, full octet, ready to go. So easy. Read the periodic table. Life is there for you. That's it. Just read it. Just read it. That's it. If you don't know how to read it, you look at your photable, you look at how we colored it, you learn how to read the periodic table. It is no use to go into something with resources. You get this on every chemistry test you could ever possibly take. Anywhere you go, chemistry, you will get a periodic table. It has so much information for you. It literally is cheating. You literally are cheating. Okay, if you know how to read this document, you literally don't have to memorize a thing. You go in, you read the periodic table, you answer the question. You don't have to know anything. That's it. Okay? Therefore, this is why I call this the Bible of chemistry. This is why it is so important that you know how to read the periodic table, because it's literally a cheat sheet. Any other questions? Alright, that is it. No more questions. You have this review that I did for you. You have the review from the day before it, 6 pages. You have your notes, you have YouTube, so on and so forth. You should also make sure you go to bed at a reasonable time. Know your vocabulary, know your vocabulary, know your vocabulary. The 3 most important things you must need to know for this test. Vocabulary, vocabulary, vocabulary. With that, have a good night. I will see you tomorrow.